y equals x e to the x. Let's have a little look at this. I'm going to draw the two curves, I think. That's the first thing to do. So the first one I want to draw is the curve y equals x. There it is there. And down this side as well. This is the line y equals x. Here. And now I'm going to draw e to the x as well. We know it goes through 1 at 0 and it shoots up. Oops. That's pretty hopeless. It's going to come down and shoot through here and then tend to 0 quite quickly. So straight away from inspection we can see that the curve we want to draw here, because that's a positive and that's a negative, the product will be negative, so we're going to be down here somewhere. And these two are positive on this side, so it's going to be up here somewhere. Now this shoots off to infinity. Now when x is 1, you're going to get the same value. So at the point 1 here, 1 times e to the 1 is e to the 1. So it's going to be on that curve there. So there's an actual point of the curve. When x is smaller than 1, these will be a fraction of those. So it's going to come around like that, isn't it? But after 1, this is going to increase the value of e to the x, isn't it? Like at 2, it's going to be double. So it's going to shoot up very, very steep. So that's what it seems to me as though it's doing. So it's going to come down from a very, very steep point here, come through here, and then go under the e to the x curve. Now, when x is 0, it's going to go through 0, isn't it? It's got to go through 0. And it decreases all the while, doesn't it? And then, okay, what happens after? Down here on the negatives. Well, as it tends to minus infinity, as x tends to minus infinity, this is minus infinity, and this tends to 0. But this dominates because it tends to 0 very much faster than this tends to a large value. So this will dominate. So we'll get negative small. So it looks like it's going to come down through here. It's going to have to turn. These values under 1 are all less than 1, so it won't turn below this line, it will turn above it. Turn on a minimum and tend toward that line there. So I'll have a go at that now. And then we'll find the minimum. I'm going to do the sketch first, and then I'll confirm it when we do the differentiation. So it's coming down really steep, comes through here, does a minimum, and then starts to tend toward there. Probably a lot quicker than the way I've drawn it. Here's our minimum. So let's do the differentiation to verify that then. Y dashed is equal to, it's a product, so it's u to v dx, which is e to the x, plus v e to the x, times du, which is x differentiates to 1. Let it equal 0, and that tells us then, take an e to the x out as common, and we get x plus 1 in a bracket equals 0, and that tells us x equals minus 1. So that marker there I can change to a 1 actually and put a minus, and that's our minimum. And we know that that value here, if we wanted to put it in, would be 1 e to the minus 1, or 1 over e. So it doesn't go down very far below the x-axis. So that looks like what we've got then. We know it's a minimum from the way we've drawn the sketch. So let's just verify that then. We want x e to the x. X e to the power x. Let's do from minus 3 to 2 to see if we can see the curve. Let's try that again, see if we can get a plot coming out from the server. Here we go. Okay, good, and that's what we thought, didn't we? We can see the minimum at minus 1 there, and it swings through 0. Interesting thing is we could also get the gradient. You could see how the gradient is at 0 in order to sketch the curve accurately. So let's just have a look at that. Here's y dashed. When x was 0, you get a gradient when x is 0, e to the 0 times 1, which is 1. So it comes through here at about 45 degrees. It's actually the same gradient as this line here. So this line is tangential at this point here. That straight line there, because that's also of gradient 1. Good.